All right, 6.7, graph linear inequalities. In two variables. All right, so what's different about this section is that now we have a y added into our inequalities. Instead of it just being like x is less than 7, now we're going to have like y is less than x plus 7. Okay, and we're going to be graphing these kinds of things. Just really quick, just so it's on your radar, this is the last section of this chapter. Okay, so tentatively I have a quiz down for Monday, but I don't love giving Monday quizzes, so we may push it to Tuesday, especially because we've had people out and stuff to make sure everybody kind of has time to play catch up. So it'd probably be Tuesday, and then if we do that, then we'll do some review and probably test Friday. But that's kind of where we're at. It looks like, yeah, looks like we're good. Thank you.
Yeah.
Did everybody one quiz for this chapter or two?
We already had one.
Even the window.
Oh,
You just don't have it back yet, but it's graded in grade link.
okay. I forgot about that.
Yeah, we had one after section 4 because all that kind of went together, and then 5, 6, and 7. Well, 5 and 6 go together. 7's kind of just its own thing, but I don't know. It all goes together in the chapter, but it's kind of its own little thing. So, anyways, when we do this, these will be graphed very similarly to when we were just graphing lines. So I hope you haven't forgotten how to graph lines since before Christmas. So a linear inequality in two variables basically looks something like x plus y is greater than or equal to 7. And so really the only difference from when we were graphing equalities to now is that the symbol here has changed. Okay, so a couple things that we need to know. A less than or a greater than, like this, is a dotted line. Okay, so when we just had less than or greater than, when we were graphing on a number line, those were parentheses. And then if it was or equal to, it was a bracket. Okay, so the or equal to as far as graphing is going to be different. So if it's less than or equal to or greater than or equal to, it is a solid line. Okay, so the or equal to will look just like your normal graphs that we did in whatever that was, chapter 3, 4, or 5, something like that. But the ones that are just less than or just greater than are going to be dotted. Okay, so what that means is when you're graphing, it'll look something like that versus this one's just going to be solid. Okay. Try to see what else section. The other thing with the graphs of them is that we have shading. So when we do these, you may want like a highlighter, or, I mean, you can use a pencil or something, but you may want like a colored pencil or something to shade with. But we shade in the direction of like what makes the statement true. So if it's, let's see, how do I want to put this? Shade in the direction that contains a point that makes the inequality true. So like for that, if I gave you negative x plus 2y is less than 8, and I gave you the ordered pair 0, 4. Okay? We're going to plug in 0 for x and 4 for y, and we're going to see if this makes a true statement. Okay? So, obviously, 0 can't be negative. So 0 plus 2 times 4 is less than 8. So I get 8 is less than 8. Is that true?
9.
Not true, so this is not a solution. Okay. What if instead I said to plug in the 0.35? So I plug in 3 for x, so negative 3 plus 2 times 5 is less than 8. So that's negative 3 plus 10, which is 7, is less than 8. Is that true?
Yes.
Okay, so this is a solution. So you're shading where you get a solution. Okay, now there's going to be easier ways to look without you having to do the math on all of them, but you can always verify if you've shaded in the right area by picking a point in your shaded region and saying, okay, does this make this statement true? So some of the first problems that we're going to do out of this section are going to be like this, where all you're doing is telling if it's a solution or not. And then we'll move into actually graphing the problems. Let's see. Let's just go ahead and jump into some, because this is a concept that I think is just easier to see with examples most of the time. So first of all, we're just going to be checking to see if the ordered pair is a solution. So, is the ordered pair a solution? So first of all, we've got number 4. X minus y is less than or equal to 5. And the point is 8, 3. So 8 minus 3 is less than or equal to 5, which then gives me 5 is less than or equal to 5. Is this true?
Yes.
So this is a solution. Let's see, 8. Negative 3y minus 2x is less than 12, and the point is 5, negative 6. What is happening? All right, so plugging in, negative 3 times, notice they did y first this time, so that's negative 6 going in there, minus 2 times 5 is less than 12. What's negative 3 times negative 6?
18.
And then negative 2 times 5?
Negative 20.
So 18 minus 10 is less than 12. So 18 minus 10 is 8, is less than 12. Is that true?
Yes.
So that one's a solution. Yes.
I can drink a water, please.
All right. 10. 0.5y minus 0.5x is greater than 3.5, and the point is 6, 2. So, knowing that I'm plugging in whole numbers and that they happen to be even whole numbers, I don't know if you like working with decimals or not, and these ones you may just know off the top of your head, but if you wanted, we could convert these decimals into fractions and just say 1/2 times y minus 1/2 times x is greater than 3.5, okay? Because when I do that, let me rewrite it. I can then plug these numbers in, and because they're even, things are going to cancel and just make my life easier, in my opinion. It's up to you. So, plugging in the numbers, 1/2 times 6 minus 1/2 times 2 is greater than 3.5. Well, what's 1/2 times 6?
3.
And then what is 1/2 times 2?
-1.
Yep, so -1 is greater than 3.5. So that means 2 is greater than 3.5. Is that true? No, so this is not a solution. Okay, so again, this is, obviously these are some problems, but this is a way we can check our graphs too to make sure that our graphs are right. Now, when we graph, we still need to set it up in slope-intercept form, okay? Even though it's not an equal sign now. What is slope-intercept form?
It's y equals mx plus b.
Yep, y equals mx plus b. This equal sign now can be less than, greater than, less than or equal to, or greater than or equal to. Okay? Yes.
I'm like a bit confused in number 10. Like, are we multiplying?
Yes, we multiplied.
So don't you have to multiply 3 into 1? Is this -1 to be 3 times -1?
These aren't multiplying. These are being subtracted.
Wait.
This is 0.5y minus 0.5x.
I thought that was -0.5. That's -1/2.
That's the same thing. Negative and minus are the same
My
thing.
brain hurts.
It's always and forever been the same thing.
My brain hurts.
All right, so this is where if you want to do graphs on graph paper, I would say get it out now if you aren't already doing that. So we're moving into graphing inequalities. So we're going to start out with 18. So this is y is less than or equal to x minus 2. So one of the first things after I see that my equation is in the right order, okay, so this is like y equals mx plus b, it's in that slope-intercept form. The next thing I want to do is I want to go ahead and note, is this going to be a solid or a dotted line? Since this is or equal to, it is solid. Okay, and I like to go ahead and write that. It's not wrong if you don't, but it's good to get used to it to make sure that you're paying attention to that. Now, the other thing, if y is less than, then it's shaded below. Okay, so underneath of your line. If y is greater than, and this is applying to or equal to as well, it's shaded above. Okay, so I typically at the beginning will either write solid or dotted, and then I'm going to write where it's shaded. So in this case, y is less than, so I'm going to shade below. Okay, those are the two things that I do first when I'm doing a graph like this. So I'm going to set up my graph here. And since I have grid lines, I'm not going to put all the little ticks on there. If you're not using that, then obviously you need to put, those things on there. I'm going to be counting by ones. So what is my y-intercept?
1.
Negative 2. Y equals mx plus b. B is my intercept. So down here at -2. What is my slope?
1.
1. That means I go up 1, right 1. Up 1, right 1. Or I can go down 1, back 1. Okay, but I have a positive slope, so my line should be going up the hill. So this one is solid. So just like we did when we were graphing lines before, I just connect the dots like this. Now, shading. So I'm going to use my little highlighter here. So I shade below. So I'm shading down here. It's not going over the line. but it's everywhere down here on my graph. Okay? If you're only using a pencil and like not a highlighter or a colored pencil or something, when you do it, you need to do something like this. Okay? So that it's evident where you have shaded. Okay? But later on in math, I don't remember if we do it in here or not, but we'll eventually graph multiple lines on the same graph, and you will be shading multiple of them. I do it in Algebra 2. And it's a lot harder if you're just using a pencil to see where it's shading, so we usually use multiple colors. But for the sake of this class, if you just want to do the little squiggly lines to shade, that's fine. Now, to check this to verify that we shaded correctly, because obviously this is brand new stuff, I'm going to pick a point down here in my shaded region, and I'm going to check it up here. Okay? Now, you don't need to check every single one of them, but it's good just to have for a resource. So, I'm going to pick a point that's over here in this area that is yellow and make sure that I shaded correctly. So, I'm going to go over, let's say, 3, -2. Let's try that one. So, 3, -2. And I'm going to check that point to just make sure that it's right in the equation. So I'm going to plug in -2 for y is less than or equal to 3 minus 2. -2 is less than or equal to 1. Is that true?
Yes.
So I've shaded in the right direction. Okay, so the number that I picked was down here. And you don't have to we could have chosen a variety of them. I could have even chosen 4, 0, and I could have plugged that one in, and that also would have worked. There's so many options that you could pick. You could pick a number way down here, but that will tell you if you shaded right or not.
Does it still work if you use like half of the interval? Like if you did like half or 0.5?
Like you use like a fraction?
Yeah.
Yes. That's just going to mean you're plugging in fractions, which most people don't like. So I just try to pick a whole number. But yeah, any number in this area will work. Like technically, you could have said 2 -1, or you could have said 2.50, and like that's going to work too because it's in the area that's shaded as long as it's underneath the line. And the reason that this line is solid is because the part that's actually on the line makes this statement true as well. So if I plugged in 2, 0, I'm still going to end up with a true statement. But on a dotted line, I would not. I would end up with a false statement. Okay? Does that make sense? All right. Let's look at another one. 20. Y is greater than or equal to -2x plus 8. All right, so is this one going to be solid or dotted?
Solid.
Solid because it's or equal to. Now, this one is greater than or equal to, so this one is going to shade above. And let's just do this as a refresher. What's my slope?
Use 8.
Slope.
-2.
-2. What's my y-intercept?
8.
8. So that's kind of a bigger number. So I think I might count by 2s just to not make my graph so big. I'm going to count by 2s on the y, but not the x. So I'm going to make sure I label that. All right, so these I'm going to count by 2s, so I'm going to block them off this time. But here I'm going to show that I'm just counting by 1s because obviously that's different. So I have the intercept at 8. So up here, I'm going to put that point on the graph. My slope is -2. That means I'm going down 2, right 1. So down 2. Right 1, down 2, right 1. And now I'm going to connect the dots. So this time I'm shading above. So it's up here. That's where y is bigger. So basically the y keeps going up bigger up here. So that's why I know it's up here. What point do y'all want to pick this time?
3, 10.
310?
Can we do 8? Because my graph only goes up to 8. And then I'm running a rule on it.
Well, but it's shaded up here. So you're going to keep, we're not plotting the point. We're just checking it. Yeah. So I'm going to check the point 310. So yes, on my graph, that would be up here, but I don't need to I don't normally plot that point. I was just doing it for reference. So 10 is greater than or equal to negative 2 times 3 plus 8. So 10 is greater than or equal to, that's negative 6 plus 8, which is 2. That's true. So I know I've shaded in the right direction. All right, 22. This one will show us something a little different. X minus y is less than or equal to negative 11. So when we were graphing lines, we had a different way of, what am I trying to say? Graphing, we graphed by intercepts when we did that, and we used the cover-up method. With these, we've got to get y by itself because otherwise we're going to shade wrong. Okay, so we got to do it in slope-intercept form. So that means I need to get y by itself. So what do I need to do in order to get y by itself?
Subtract x.
Subtract x. So I have negative y is less than or equal to negative x minus 11. Now what?
Divide by negative y.
What happens when I divide by a negative?
The sign flips.
So that's still true when we're graphing. So this was a less than or equal to. Now it's greater than or equal to. And that'll be x plus 11 because I divide everything by the negative. All right, so now, am I solid or dotted?
Is solid.
So this one is still solid. And then which way is this one being shaded? Above, yep.
Above.
All right, so this graph, well, let's do this actually. What's my slope?
11. No, I 1.
Intercept?
11.
All right, so again, pretty big number. To keep my graph kind of small, I think I'm going to do 3 on the y-axis and 1 on the x-axis. Maybe I'll do 2 because 3 is kind of a weird number. I'll do 2. Easier to split. All right, so I have intercept at 11, so that's up here halfway between. Now my slope is 1, so that means I go up 1, right 1. Or my graph's not big enough for me to keep going up. I can also go down 1, back 1. Okay, then connect the dots. So this one was getting shaded above, so that means up in here. So on this one, I actually can pick a nice easy point. I can make x 0, and I can choose any number up here. So let's do 0, 14. Let's try that. So plug in 14 for y, 14 is greater than or equal to 0 plus 11. So 14 is greater than or equal to 11. Is that true?
Yes.
So I shaded the right way.
Do we have to check them on the homework?
No, you don't have to check them all. But while you're getting used to it, or when you get to the quiz, you probably should check them, because I have people shade the wrong direction all the time, and if they just would have taken 15 seconds, they could have realized that they shaded wrong and have not gotten the problem wrong and lost points. 26. Trying to find one that's not or equal to. Y minus 4 is less than x minus 6. So y's got to be by itself, so what do I need to do?
Add the 4.
So y is less than x minus 2. Is this one solid or dotted?
Dotted.
This one is dotted. And is this one going to be shaded above or below? Below. What's my slope?
1.
Intercept?
-2.
So I'm going to set up my graph. I'm just going to count by ones. So normal this time. All right, so I've got intercept at -2, so that's down here. Slope of 1, so up 1, right 1, up 1, right 1. Now, when I go to draw the line, notice it is dotted, okay? So I'm going to do little like dashed lines, okay, all the way through like that. Not connected. That's what indicates to me that it is just less than or just greater than, depending on the situation. Now I shade below. So that's down here. And since we've been checking all the other ones, I probably won't check. Well, I'll check this one since we haven't done one that was just less than or whatever yet. Let's check the point 30. This will probably be the last one that I check though. So and I can even check it in the original, or I can check it in this modified. Either way is going to give me the same thing. I'll just do the modified one. So 30. So 0 is less than 3 minus 2. 0 is less than 1, which is true. So I shaded correctly. All right. Something that's a little different. 30. X is greater than or equal to 5. What's different about this one?
No Y.
There's no Y.
No negative.
No negatives. So, but this one is still getting graphed on the coordinate plane. Okay, it doesn't say to graph it on a number line. So this is a little bit different. When we had x equals 5, how would we graph that?
Just like a straight line.
It'd be like 5 to the side.
Up and down.
Up.
Okay, at 5. Same thing happens with this one. So,
I'm not wrong.
all right, so over here at 5, is this solid or dotted?
Solid.
Solid. I have a straight line up and down here like this. Now, this one is greater than, okay, but it's x, okay? So I need to shade where x is bigger than that line. Where is x bigger than, on the right or the left?
Right.
On the right side. So this one gets shaded over here. Okay, so if I chose 7 and plugged it in, 7 is greater than or equal to 5, so I'm good. Okay.
So weird not hearing Sam say.
Good question.
Good question.
What do I do? How do you do it?
I'm me.
So like, what is
So
that?
So
Yeah,
like,
are we supposed to check it?
I just did. All right, 32. Y is less than or equal to 4. All right, when we had a y is equal to something, what did we do? Actually, I'm going to make this one just less than. I'm going to modify it. Huh?
No, you do the line the other way, right? Because it's y.
What do you mean the other way?
And then
Yes.
the
The horizontal line this way. Notice I changed the problem. It was or equal to, but I'm tired of having solid ones, so I changed it. So at 4 on the y, I'm going to have a straight line going across. 1, 2, 3, 4. Now, I changed it so it's just less than, so this is now dotted. So it looks like that. Now, y is less than, so where do I shade?
below.
Alright, so if I plugged in 2 for y, 2 is less than 4, so I know I shaded in the right direction.
This highlighter's bad.
Yeah, my highlighter's
My highlighter's alive and free. I'm
It
gonna
wasn't-
use
you
my
said
blue
like a
one.
race.
I'm gonna use my blue highlighter.
Quick,
All right.
why are you holding it like that?
Because
One
she
more.
had to
I'm going to have you guys try this one by yourself. This one's going to require a little bit more initial math to get y by itself, okay? Now, if y ends up on the right side, just like when we were doing the inequalities the other day, if I had 8 is less than y, like that, I had to flip the whole thing so y is greater than 8, okay? The same thing is true with problems like this. If your y ends up on the right, you've got to flip the whole thing over, okay? Or you're going to end up shading in the wrong direction. So, take a minute and do this next one. 33, and it takes one off of your homework, so.
Yay.
3 times x minus 2 is greater than y plus 8.
What the fart? You don't say those words.
That's not that bad.
Grace.
All right, so work on this one.
You say that.
I don't say funny words. It's not cool.
Let's do this. Before you graph it, once you've solved the math and get y by itself, stop. So we can make sure everybody's on the same page where we are with that, because I don't want you to graph it wrong.
Might be a wee bit too late.
Well, just stop where you are.
Alright, buddy.
So once you have y by itself, just put your pencil down, look up or whatever, so that I know that we're good, because I want us to check that before we graph, because I don't want us to graph wrong just because we have the wrong math. All right, what did we get for, like, y is what?
Y is less than 3x minus 14.
We agree? All right, so this should be where we're at. So then now use that information and graph, and you probably are going to want to scale it a little different than normal just because that's kind of a big number.
I draw a straight line. Okay, wait. I can fix this. I fixed it. Okay. Just pretend it's a dotted line, okay? I realize what I did wrong. I won't be stupid.
So if that ever happens, it's a good teaching moment. If that ever happens and you're not using pencil, okay, which on anything you're turning in should be done in pencil. But if you're not, okay, then draw a little line to it and write dotted. Okay? Don't just assume that I'm going to be like, oh, ha ha ha, they knew it was dotted. Okay? Mark what it's supposed to be so I at least know, hey, you realized I did it wrong.
My blue one.
You don't have to check it. If you want to, you can. All right, do we have our graph?
No. Yep.
Are we ready to go over it at least?
Yes.
Yeah. I don't think I'll figure it out.
All right, so my intercept was down at -14. I had a positive slope, so it was up 3. So I actually counted by 3s. So I just went up like a little bit past whatever the line was so that it was increments of 3 and then over 1. So I did 1 on my X and 3 on my Y. And then it was shaded below and it is dotted. So just so that y'all can actually see what I was talking about. Let's say I had accidentally made this solid and I couldn't erase it. Okay, I was stuck or whatever. So just do this and write dotted. Something like that will tell me, hey, I messed up, but I know I'm wrong, but I can't go back and redo it without redoing the whole graph, right? It's pretty hard. If you accidentally do dotted and it's supposed to be solid, real easy to fix. If you accidentally do solid and it's supposed to be dotted, it's a little more difficult to fix if for some reason you're not using pencil. Okay? All right, any questions? All right, so look, here's the deal. We only have a few minutes left of class. I didn't think this section was going to take this long, but it's fine. So tomorrow what we're going to do is you're going to have class time tomorrow to work on this. Okay? If you guys go home and all do this tonight, you're going to have worksheets tomorrow. Okay? The idea is that you don't have homework tonight. Okay?
So are you encouraging us not to do it?
If you want to have worksheets to do in class tomorrow and have twice as much work, then
Jonathan, don't do it at
Don't
home,
do it.
please.
Don't do it.
I
please.
might.
No.
Jonathan.
He's probably already done.
if that's the case, I just won't give you the problems right now.
Yeah. Don't tempt me. Do not tempt me.
Jonathan.
He can
Okay.
figure it out himself.
Don't give us the
He'll figure out
problem.
all the problems.
I'll just do all of you at once. Can't go wrong if you do all of them.
No,
Don't give us the
Then
problem.
you'll be doing way too many because I didn't give you that many.
Can't go wrong.
All right, so I'll just give them to you tomorrow when you come in then,
Yes,
because there's
yes.
only like 2 minutes left. And anyways, but that being said, the quiz is gonna move to Tuesday. Okay, not Monday. The quiz will be Tuesday, and then your test will be next Friday on chapter 6. Okay, so we'll have a couple of days to review in there, which is obviously never a bad thing. So
What lesson is it?
it'll be 6-5 to 6-7.
6-5 easy, 6-6 easy, 6-7 slightly harder but still easy.
So.